This is Maya, Shijin, and Tucker's silver-copper reaction chemistry video. Alright, this is a lab, so you need some common safety stuff. You should wear gloves. You should be wearing goggles, definitely. And if you have short sleeves, lab coat, or if you're handling acids, that would be a good idea to wear a lab coat. And then you should also have long pants like Shijin over here, and closed-toed shoes.
Copper wire, a 150 milliliter beaker, a test tube, a ring stand with a ring clamp, a funnel, a pencil, a watch glass, solid silver nitrate, a wash bottle with pure water, a 50 milliliter graduated cylinder, and a scale.
Okay, so now we're actually going to do the lab. First thing you're going to do, get a 30 centimeter length of copper wire and wrap it around a pencil to form a spring.
You will get this when you are done.
You should put it in your test tube and it should fit exactly in there, so that way when you add the solutions in, it actually reacts with the copper instead of just leaving the copper. So it should look something like that. Alright, weigh the coil wire on the balance scale, or just weigh it on your normal scale like we have, and then record that on your data table. Put that back in there. And we already weighed out our silver nitrate. You should have 1.5 grams of silver nitrate, and you should put it in the beaker right there. But make sure you're going to measure it on top of the filter paper. So the filter paper, measure that before you measure it with the silver nitrate, and this weighs about 0.3 grams. So with the 1.5 grams of silver nitrate, it's going to be 1.8 grams total. Okay, put 1.5 grams of silver nitrate into the beaker, which we did already. Weigh the filter paper, which we did already. It's 0.3 grams. Okay, pour 20 milliliters of distilled water into the beaker, which we did. Okay, use the stirring rod to stir in the silver nitrate and the water until the silver nitrate is completely dissolved in the water. Don't spill any of this stuff because there's real silver in there. Okay, now stir until the silver nitrate is completely dissolved into the water. Okay, now add the silver nitrate solution to the test tube with the copper wire in it. Then wash out the container that had the silver wire and silver nitrate, and once you add the silver nitrate water solution with the copper wire, it should start to react and form real silver, which you can see here. So you should have 10 observations about this, so start your observations.
Now the silver and then copper reaction is already done, so it's time to get the silver off.
Alright, so what we're doing is we're shaking the silver off, which is one of the last steps in the lab, and then we're going to pour it into the filter paper, and we're going to rinse it off, and then we're going to wait for it to dry, and then we're going to measure the silver that's produced and the copper wire to see how much mass the copper wire has lost.
Just get the idea. And this test tube is far too small for this to work properly. So yeah, just... So when you put the filter paper in the funnel, it's going to do that. Not very useful. So what you want to do is put some water in it, get the paper wet. Get the paper wet and push it down so it sticks to the funnel, and it will look like this.
And then it's useful.
So you can pour things in it and it won't overflow.
Okay, so now take the filter containing the silver out of there very carefully. And keep the silver in the filter paper because that's its container, and put it on some paper towel, and then also take the copper wire that you reacted with the silver nitrate and put that on the same paper towel, and you're going to want to let those dry overnight, and then measure the copper wire to get the amount, and then you do some calculations to get the amount of mass lost. And then you measure the filter paper in silver, and since you already have the mass of the filter paper, just subtract the mass of the filter paper from the mass you get when measuring again, and that'll give you the mass of the silver. Okay, now it's time to measure the copper and the silver after the reaction when they've dried. Okay, and then now it's time to measure the amount of silver we produced.
The oil and the silver nitrate is 30.6 grams, and then the oil is 29 grams, and then the silver nitrate is 1.6 grams, and copper is 3.4 grams, and then the copper after reaction is 3.2 grams, and then the filter paper is 1.86 grams, and then the silver is 0.96 grams.
That's the mass of the silver nitrate, the mass of the vial plus the silver nitrate. 0.6 grams, and subtract the mass of the vial, 49 grams. That gives you 1.6 grams of mass of silver.
Okay, we need the moles of copper, the silver we've made, the amount of copper atoms lost, and the amount of silver nitrate that there was originally. So, the math. You set up a basic equation. You have the grams here to convert to the amount of moles, and so you put the number of grams of silver, and then you have 1 mole multiplied by 1 mole divided by the mass of the silver, and then you multiply that by the basic mole, and then you divide by the amount of moles, and you get the number of silver. And then the copper before the reaction is the same thing, and then you get this number, and then you put that in your data table, and then the copper after reaction, you take the amount of copper that you got after the reaction, same thing, and then you get this number, and then you put that in your data table, and then the copper after reaction, you take the amount of copper that you got after the reaction, and you multiply it by 1 mole divided by its mass, and then you multiply that by the mole number to get rid of the moles, and that's the number. And then you also have to write a balanced equation, and that is the copper plus AgNO3 times H2O equals copper times NO3 times 2 plus Ag plus H2O. And the thing that's unbalanced is the Ag, so you add an equal amount, you add 2 Ag on either side, and it's balanced. And that's our calculations.
This practice. Are you done?
Wait a minute.
With
a this one is
ring
small stand and then
maybe